Okay, electric bike version 3. Now if you're wondering why there was no version 2, I never made a YouTube video for version 2 as that was my, basically my high school graduation capstone project. So I didn't really document it on YouTube, but here are some snippets. It was a much better full suspension mountain bike than my version 1. It had a lot more power, different motor, totally different gearing ratio, so that was pretty fun. Now I am on version 3, and I kind of want to do something different. I want to try my hand at a friction drive system, so let's get started. I need to drill out that hole, which is 32 millimeters. That's a little bit tricky for me because I actually don't have anything that can drill. Well, I do actually, but it's not. It's kind of what I'm going to explain right now because it's not the best idea. So I do have this step bit that goes up to 32 millimeters. That's literally the last step. I know this is not how you're supposed to use a step bit. You're only supposed to use it on fairly thin material. But right now that's kind of my only option because I don't want to get drill bit that big. So my plan is I'm gonna drill this hole as big as I can, which is 3/8, and then I'm gonna start using the step bit. Basically what I'm thinking of doing is I'm going to use the front derailleur shifter to engage and disengage the pulley. That's my idea. So when I'm riding it, I can remove the cap and whatever, and attach it on there. I'll redo all the cabling and stuff because it's really rusted. Okay, so I'm going to quickly explain what I've kind of been doing because I haven't really explained it really well. So, motor mounted here, the belt system's around there. So what I have right now, I have a spring and I have a pulley system. This is kind of like, I don't know, this allows me to move the shaft back and forth. There's a bearing on the inside that's on some ramps that'll basically keep the drive belt constantly in tension. I have this paracord that goes around this bearing that just hooks onto here. It's really solid. And then that goes up here. And then what I have here is these two basically connect to this block. And in this block has the shift wire. And that shift wire goes up to this little retainer bracket thing that I printed. And that wire goes, you can't really see it, but it goes up over the seat, under the seat actually. And then down here, and basically goes into the shifter. So what that allows me to do is, my idea was to engage this with the shifter and then have it spring back so basically like a shifter, but instead of shifting gears, it's pulling the rubber pulley thing, I guess friction wheel, and contacting the wheel. So as I pull the shifter, you can actually see goes in again. So that's actually quite tight. So as you can see, I'm gonna release it, right, and tighten. So there's a lot of loose ends right now, but that'll spin freely. And once I put this, contact that, gonna contact that quite well. It's not super tight, like I can still spin it, and I'll still have to play around with the tension to see how much force I need to push into the wheel to get enough grip. My backup plan is to put grip tape if it still slips. I want it to perform decently well in the rain. I don't mind if it slips a little bit, but I wanted to. My main idea is I wanted to disengage like that, so I don't get any resistance. And then what's cool is if I want regenerative braking, all I gotta do is to click this back on, and then it'll just go back into the motor and regen. So I have the option of turning that on and off, which is pretty nice. Okay, so you're probably wondering how I'm gonna mount this battery, which weighs 8 kilograms, onto there. Obviously the easiest way is to just stack it up onto here and just like strap it down or whatever. But I'm thinking a better way might be to mount it on the side like this, because that'll lower the center of gravity, so the bike won't be so tippy. And then I'm thinking if I get a pannier raft bag or whatever, I can droop the sides over, and I can cover that and even put stuff there if I need to take some things anywhere. So that it'll kind of conceal the battery, so it won't look too obvious that it's an electric bike. And yeah, I'm gonna do that right now. This side will go on and clip like so. That clips on there. It's pretty heavy. Alright, this is genuinely the first test. There's a hummingbird in the background. Ooh, that's way too slack. It's another day. I have this mounted now. It has the grip tape. Yes, I gave in the grip tape. When I tried it one night, it just slid like it was nothing in the rain. Right now it is wet, so I can actually try if this works. Right now it's kind of in the worst conditions. And yeah, I'm just waiting for that battery to charge up. So what's nice is I can actually adjust the tension by turning this in and out, so I can adjust how hard it presses against the wheel. Okay, so basically that didn't really work. It actually worked in the beginning. The grip tape was gripping the wheel a lot better than the wheel without grip tape, up to the point where I could almost go full power actually, but I wasn't doing it very fast because I was in my backyard. The issue is, once I started using it quite a bit, like doing more circles, so not even that much, I noticed, oh wow, okay, it can start slipping a little bit, so I thought it was some tension or whatever. So then I twisted the shift adjust thingy out by on the handlebar, and it worked for a bit, but then it started slipping again, so I was like, okay, it's not that definitely. And then I look at the grip tape. Basically, all of the grains or the rocks for the grip tape are not there anymore. It's smooth. So okay, well obviously that isn't a reliable solution. So what I decided to do was I made this. So this is not made out of flexible plastic anymore. It's basically like a spline almost. It's a bunch of teeth that my idea is that is going to be my grip. So that will bite into the tire, and this should not wear out nearly as fast as this one did. So I'm gonna swap this over. Okay, so I installed the new I guess I'll call it like friction wheel. So I'm going to power it on and test it. It might sound different actually. It might sound cooler. So right now, spin straight. That's just, it's not attached, so I'm gonna attach the wheel. And okay. I'm gonna try it out tonight. I'm not gonna video it, it's just so dark. Man, this project's going on forever. Alright, so it does work. So I didn't exactly document every single thing because I've actually gone through a lot of versions of this motor mount and the friction wheel, that's what I'm calling it, and just how everything came together. It's just so much trial and error because I just had to experiment with a bunch of different things to get it to work. So I actually have this bin full of parts that I just printed. Like, that was one of the first few versions, and this one was one of the later ones where it's getting closer to that. But yeah, lots of different friction wheels. I tried one with like a little spline so I can change it out depending on what I want. But in the end, I figured out this ratio because I have to change the ratio by increasing or decreasing the diameter of the friction wheel. As for the motor, right now it's just a 1-to-1 12 tooth from the motor to the friction wheel drive, and that's just done through a synchronous belt. It's those belts are like for electric skateboards. So as for the batteries are 8S, so it's not that high voltage. It's about 32, 33 around there when it's being discharged. So for the range, it's a little bit weird. You can't really calculate the range, so I don't really have a clear estimate. I've never run the batteries down because these batteries just have so much like energy in them, so I've never run them down. The problem with the range is the VESC knows how many times the motor is turning, it knows how much power the motor is drawing, and it knows the current state of the battery. So with that, it can calculate range. But the issue is, since the system allows me to engage and disengage the motor, when I'm coasting, the motor isn't turning at all. So the VESC just thinks it's stopped. So because of that, I can't calculate the range properly because you're gonna be because when you accelerate or when you coast, it's gonna be a little bit different. I'm estimating this range to be well over 100 kilometers though. I've ridden around a neighborhood several times. The batteries just dipped like a few percent. I mean, the batteries are great. These battery modules are from Nissan Leaf, the 2017, I think. From factory, these 4 modules, they will hold about 2 kilowatts in this arrangement. I'd say it's maybe degraded to about 1500 watt hours, so it's still really good. So as for control, I'm still using just an electric bike ADC thumb control. So I am able to shift in the rear, but I'm not able to shift through the front because I'm using that shifter and cable to run the mechanism to engage and disengage the friction wheel. So as for safety, if there's a fault or whatever that the VEC decides to run full throttle open, I mean, with this system I just disengage it and the motor just runs full beans, not being connected to anything. So I can still slow down, hit the brakes or whatever. Also, I can just unplug this. This is the 3-phase wires that go to the motor, or I can just click back here. This is on, this is off. So each battery has their own 125 amp breaker. So yeah, some of the things I did notice while using the bike, it is on the loud side. It's definitely way louder than a traditional hub motor. I'd say it's still louder than one of my previous bikes, like belt drive. So as for torque, you need to get the right balance, because if you make a very small friction wheel, like I did, I tried it, and the motor just kept slipping. What I would have to do is reduce the current and then limit it to whatever, like 400 or 500 watts or whatever, to get it to not slip. So you can get that, but then you'll have low top speed and whatever. So you have to really size it for the motor. And this motor, I don't think it's really the right motor for this. It's basically a 1/5 scale RC car motor, and you don't need a motor this big, that's for sure. You can get away with a much smaller motor, because I think through the system I'm only drawing about 1000 watts. But even when you're accelerating, you don't draw 1000 watts right away, because the power chart, it's not just straight power, there's a curve to it. Yeah, but other than that, I think the system it works well actually. It works better than I thought it was going to be. I thought I would just have a bunch of slipping issues. I wouldn't be able to put enough pressure and whatever. But no, I was able to get enough pressure so that it doesn't slip. The drive wheel does wear out. I'd say every 100 kilometers you need to change it. So yeah, it's kind of frequent. But if you have a 3D printer, print out like several, and you should be good for the next while. So I guess also as for weight, I'm not gonna pretend that this is like the most lightweight bike in the world, because it's not. This bike is actually really heavy, mainly because of these batteries. You can put a much smaller battery in. I just wanted to use these batteries because I already have them, and the range is just super long on these, and these are really nice, good quality batteries. The weight you'll see in this video is like 82 pounds, I think. It's very heavy. The center of balance is like here. It's kind of funny, it's like on the seat. So when you're riding it, it's a little bit weird at first. It's not a whole lot different to a normal bike. If the bike starts tipping, you gotta push on it. It's pretty heavy. It's pretty top heavy. I've tried to lower down the batteries as far as possible, but once you get up to speed and your wheels are turning, it rides just like a normal bike. What's funny is the back brake is very effective now, because there's so much weight on the rear wheel. You can just squeeze that as hard as you can, and since it's rim brake, so it's not the best, your rear wheel can slow you down almost as much as the front wheel can, so that's pretty cool. So all in all, yeah, I think it was a pretty fun project. There was a lot of designing, 3D printing, prototyping, blah blah blah, before I got to this final version. I think this design does have a little bit of potential. It's easy to adopt into a bike because you just use the derailleur. I kind of like to think that, you know, even this isn't a whole lot of power, but this could be used for commuting or just getting from point A to B. And what's nice, if you run out of battery or you have a problem and you can't use the motor or the battery or any electrical, you can just flick the mechanical switch, move the friction wheel out, and it's just basically like a normal bike with a little bit of extra weight. So yeah, I think that concludes this project. Let me know down in the comments if any questions you may have on this project, or any feedback you may have, and just let me know any suggestions you have for me for other projects or anything to do. So yeah, thanks for watching.